Facebook broadcast. Today we're going to focus on eyepieces, but to help along the process of understanding eyepieces, we're going to talk about a little telescope first. So as an example, I've got the First Light AR 80 millimeter, 640 millimeter focal length telescope on a Twilight Nano mount. The mount is a very simple left, right, up, down, and this one's been back in the warehouse and is cold, so the grease is a little stiff right here. And so, you know, warms up or just work it out and it moves much easier. So I want to look real quick here. The lens cap has a dire warning, as does the cap that's on the other piece of the telescope. They tell you the same thing. Anytime you're looking at a telescope, you do not want to look at the sun because, you know, your eyeballs, there we go, your eyeballs don't like to get burned by the sun. So the warning here is twice. Don't use these. I'm gonna back this up a little bit. Looks like it's out of focus. Don't use a telescope. Yep. Move it here. There we go. There we go. So don't use one of these, a telescope, to look at the sun. So I'm gonna pop the lens cap off, which reveals inside is an 80 telescope with an 80 millimeter aperture, very generous wide aperture. The glass inside, the two glass elements are fully coated. So there's glass on the inside and outside of the lens cell. It has an 800 millimeter focal length. It comes with a red dot finder right here, a 25 millimeter Plössl back here, right there, and a 90-degree diagonal. Now this telescope is a 1.25" eyepiece telescope. It does not take the larger 2-inch eyepieces, but we're going to use this telescope in a couple of pieces of math. So I thought it'd be interesting to talk about this telescope to start with. This is the First Light AR 8640 Twilight Nano telescope. Retail is $239.99. So Twilight Nano is a full-sized.
Kent, as shown in the carousel, it's with a different mount. That mount is the tracker mount.
Okay.
So we're in the carousel. This is Paul, the director. You're going to see the tracker mount option, and that's $6.99, I believe it is. Whatever you're in,
yeah,
Amazon,
something like that.
Yeah.
Okay, so this is $239 as we show it here. On other live broadcast, it is going to show up as a different product. So
that's with the Nano mount, right?
Anyway, this is on the Nano. That's correct. So let's talk about eyepieces real quick. The Explorer Scientific waterproof eyepieces are a spectacular value for the money. They're waterproof, meaning they're purged with argon. All the air is pushed out. The argon goes in. The argon is dry. It does not hold moisture, and then it's sealed up. So it has O-rings that seal it inside the eyepiece, and then no air is in there with moisture in it, so they can't fog up no matter the temperature exchange. So they're waterproof. That prevents internal fogging. So let's move on to, well, let me show you an eyepiece real quick. Prop these up here. These are the 40 millimeter, which is a 2-inch, and the 20 millimeter, which is a 1.25" eyepiece. You can see the difference right there in the size. There we go. So this eyepiece would not fit on the telescope we just showed you because it's too big around. But we're going to use this as a demonstration of how this math works. Okay, so magnification. Everybody wants to talk about magnification in a telescope, and they think they want to get the most magnification they can. Well, so let's talk about magnification real quick. A little bit of math. It's a simple formula. It's focal length. It's focal length of the telescope, in this case 640 millimeters, divided by the focal length of the eyepiece. In this case, 40 millimeters right here. What does that yield? 16. So if we could put a 40 millimeter eyepiece on this telescope, it would be 16 power. So this is a 20. So if you divide 640 by 20, that would be 32. Okay, so double 16, 16 is 32. So every time you go from 40 to 20, you double the magnification. So this is 32.
Genius Cat's up on the screen for you, Ken. He's got your little
Oh,
explanation.
look, we have a Genius Cat who's doing math for us on the screen. So the 640 millimeter focal length divided by the 40 millimeter focal length is 16. That's in the 40. If we go to the 20, so you divide 640 by 20, 40 will go in there 32 times. Now, continuing on, if we go to the 10 millimeter right here, that means it would be 64 power. And if we go to the 4.5, this is a little bit harder math and I didn't do the math. So the 4.5 shows up as 128 power, a little bit less than that. So some really hefty magnification. So that's a real quick primer on magnification. Each time you double the size down, the magnification doubles. 40 to 20 to 10 to 4.5, which might as well be 5 for our math, creates a situation where you can do some simple math. Now, when buying eyepieces, I really concentrate on and advise customers to not think about going, they all want to start out buying just these high-powered eyepieces. The problem is very difficult to find something in the telescope with a super high-power eyepiece in the telescope. So you're able to start with a wide field. In this case, we'd have to start with a 20. Right? So we start with a 20 on this telescope because it'll fit. It's 1.25 inches. And so we'd start out at 32 power, and then we would go to 64 power, and then 128 power. If you start out trying to find, say, Saturn, or even something big like the moon, you're not going to find it if you start out at high power. Start out at low power, get it centered up as best you can, right? So look through the telescope, get it moved up and centered. Then switch eyepieces real quick to the next size. So go from the 20 to the 10, and then from the 10 to the 4.5. So that's magnification. People crave that magnification, but my advice is to start out with a nice low power eyepiece in the telescope. So this is the 52-degree series of eyepieces. And let me show you the boxes and they come in. The boxes themselves are works of art by Will Tirian, who we have a Will Tirian planisphere. And I'll get these set up right here real quick. These things are beautiful boxes with great artwork. Depending on the production run, there's 2 styles of boxes here. The blue one and the white one, they're both absolutely gorgeous to look at. And there they are right there on top. They also come with this handy velveteen pouch to help protect your eyepieces. As you can see, they also come with a eyepiece lens cap and a telescope side lens cap to protect your optics. While they are argon purged, the glass can get scratched up and damaged, so you always want to protect those eyepieces as best you can. Prices today, $179 for the 40, $119.99 for the 20 and the 10, and we end up with the 45 millimeter eyepiece at $89. Now, these are in our 52-degree series of eyepieces, which means this is our quality, high quality, well-designed entry-level eyepiece. These are really good eyepieces. They're affordable, yet they give you a huge quality advantage over other Plossl type eyepieces that will compare in value. So let me show you what's inside of an eyepiece real quick. This is pretty cool. We have an eyepiece, and this is an 82-degree 18 millimeter eyepiece right here. And as you can see, we've cut it in half. So this shows all the things that are inside an eyepiece. We'll have people who wonder what's inside an eyepiece, and they will unscrew it to take it apart to see what's in there. Well, when they do, they break the seal from the O-rings, and the eyepiece has lost its purge and it no longer works. So that's pretty cool, seeing what's inside and how this works See, there's where you look through right there. Here's the piece your eyeball looks through, and these various elements of glass all the way through. This is a really cool device we have to show people what's inside. Now I'm going to jump up to the 82-degree eyepieces now, and the difference in eyepieces in field of view is, imagine you're standing 8 feet away from a wall, and there's a window that's this wide. So we'll call that a 52-degree field. We have 62-degree eyepieces with 62-degree apparent field, 68, 82, 100, or 92, 100, and 120-degree apparent field of view. What that apparent field of view refers to is when you hold the eyepiece up and look through it, the angle, the apparent angle that you get from looking through the eyepiece. So there's also a true field of view that involves some math that we don't want to get into, that you actually get when you put this on a telescope. So that degree, 82 degree, refers to an apparent 82 degree, which is almost 90, right? Just a little bit shorter than 90 degree, when you hold it up to your eye and look through it. So these are our 82 degree series of eyepieces, which are our most popular set of eyepieces. We have the 14 millimeter and the 6.5 millimeter. These are also argon purged, waterproof. They're $229.99 for the 14 and $269.99 for the 6.5 LE. Now, what does that LE stand for? That LE stands for long eye relief. And what that means is the distance that your eye can get to where it comes to focus. So this has a couple of more millimeters of eye relief than the similar, I believe it's a 6.8 or something like that. This eyepiece gives you more eye relief, which makes it easier to see. Now then, 2 millimeters doesn't sound like much, but when you're talking about 8 or 10 millimeters, it can mean a matter of comfort. So we're gonna go ahead and end here with the broadcast. Look forward to seeing you. Thank you for watching, and everybody have a great day. Oh, I'm looking at the chat, just saw it. Hello, Pekka, nice to see you today. Remind everybody to check us out and buy some eyepieces. I'm Kent with Explore Scientific. Have a great day.